Name the blood vessel labeled X in the diagram. Well, it's going away from the heart and to the lungs. It's the pulmonary artery. Okay. But blood is pumped from the heart to another organ through vessel X. Name this organ. It's pumping blood towards the lungs. Okay, so we got lungs there. Okay, now we're on to the next part. 2. A doctor takes a patient's pulse by listening directly to the heartbeat using stethoscope. Describe another method of taking a pulse. Well, you can use your fingers to find a pulse in your wrist. Your wrist. There you go. What's the average pulse rate per minute for an adult arrest? Apparently it's 70 beats per minute, plus or minus 4 was the margin of error they gave us in this one. You go up, you can see the marking scheme here gave us 70 plus or minus 4 there. Okay, so let's move on. Question 3. State a function of red blood cells and a function of white blood cells of the plasma in the blood. Red blood cells carries oxygen around the body. Well, the plasma, you can say the plasma kills the body, or I think it believes it carries food around the body as well. Carries minerals, nutrients around the body. Okay, so plasma does that actually, as it turns out. Carries minerals and nutrients around the body. Okay, question 4. The blood vessels marked A and B carry blood away from the heart. A is the pulmonary artery, we already did that earlier. And then B is the aorta, which is the largest vessel in the heart. It's the main artery that carries most of the blood away from the heart. Okay, question 5. State the function of white blood cells. White blood cells are used to fight. White blood cells protect the body from. White blood cells are used to fight infection. State the function of red blood cells to carry oxygen around the body. Now, if you're wondering for other acceptable answers, we could have had white blood cells fight infection, produce antibodies, engulf, destroy bacteria, kill germs, and red blood cells is simply to transport oxygen. Okay, so that's no big deal there. Let's move on. Why is blood considered to be a tissue? Well, it's considered to be tissue because it's a group of cells working together for the same function. Name a substance transported by blood. You could say oxygen, nutrients, oxygen, nutrients, minerals, technically carbon dioxide as well. So we'll have a quick look at that one as well while we're here. Any one from the following: oxygen, carbon dioxide, food, wastes, hormones, water, minerals, vitamins, cholesterol, anything for that part B. Okay. Now, next one. Name the blood vessels labelled A and B. A is the pulmonary artery, again. Oh, sorry, no, it's the aorta. My fault. A is the aorta. The aorta carries blood to all parts of the body. Oxygenated blood goes into the capillaries, loses its oxygen, and then what happens is its deoxygenated blood enters the vena cava, which is B. Capillaries are small blood vessels. Describe two changes in the composition of blood after it has passed through the capillaries of the lung song. It loses oxygen. This is the first one. And number two, it gains carbon dioxide. Okay, so those two things are done and dusted. Loses oxygen, gains carbon dioxide. You could say carbon dioxide removed less oxygen. Okay. Now let's go back. Oh, sorry, my fault. Capillaries of the lungs. Sorry guys, I was doing the capillaries of the rest of the body. Sorry, always check your answer. So capillaries of the lungs is it gains oxygen because you go to the lungs to gain oxygen and you go to lose carbon dioxide. So I'll check that answer. I thought it was here, but we're actually talking about the capillaries of the lungs where it goes to gain oxygen. So it's my bad. Moving on. What feature of capillaries allows these changes to happen? Capillaries are only one cell thick. One cell thick, okay? So thin walls are one cell thick, and this allows capillaries to transfer oxygen and carbon dioxide through the walls of the capillary. And then the chamber of the heart that pumps blood to the lungs. Blood to the lungs. So to the lungs would be this blood here on its way to the lungs, which means it comes from here, which means it comes from the right ventricle. Okay, the other side is the left ventricle. So this is the right ventricle. Okay, let's move on. Label clearly the pulmonary artery with A. Pulmonary artery is A. Label V, the pulmonary vein, that's V. Alright, done. Next part. The diagram shows a cross sections of an artery and a vein. Why do arteries have much thicker walls than veins? They pump blood at high pressures. / speeds, okay, around the body. Give another structural difference between arteries and veins. Veins actually have valves. Because veins, the blood's running a lot slower. When you're going up, let's say you're going from the leg back up to the heart, you need veins to stop the blood leaking back down. Okay, so you need valves. Okay, so veins have valves. Okay, if we come down here, we might have a look at what we see here. Digestion. No valves in arteries, veins have valves, and then a higher blood pressure in the arteries. Okay, so that answers question 9. Okay, let's go to question 10. Study diagram, human digestive system, state 1, function of the stomach. Churns to mechanically digest food. It also uses acid or stomach acid to soften the food, whichever one you want. Now, what is, I think Y is the liver, okay, which is used to make bile. Okay, digestion, breakdown of food. So the stomach can be for digestion, produce acids, produces enzymes, or churn food. So any of those answers is good. Okay, next question. What is digestion? Digestion is the breakdown of food. Excretion is the removal of the waste from food from the body. Okay, so look there, removal of waste, breakdown of food. Okay, we're all good. That's question 11 done. Question 12, diagram shows the human digestive system. Which organ of the human digestive system does the esophagus carry the food? Well, it carries it to the stomach. State one function of the liver, to produce bile, which is an enzyme used to digest fats. To digest fats. State one function of the large intestine. You can say to carry feces to the anus, or to carry waste to the anus. Alright, we'll have a look at that now. Sometimes I'm a bit hazy on this stuff. The liver produces bile, detox center, breaks down proteins, regulates body temperature. Liver does a lot of things, breaks down red blood cells. The large intestine does reabsorption of water, carry feces, so that's what I said, accommodates useful bacteria. So you can use any of these answers for part 3 if you want. And part 4, mouth, stomach, small intestine. Let's see what the last answer is. Now part of digestion where both mechanical and physical digestion occurs. Well, the obvious answer is the mouth loses salivary amylase in your saliva to break down sugars or food, and you can also use your teeth to break down the food. Okay, so that's the best answer for that one. Most of the food we eat requires digestion. What is meant by digestion? Digestion is the breakdown of food. Why do we need it? To provide energy for our body. Once again, you can have a small peek at the market scheme if you want. Breakdown food so that food can enter our bloodstream to make food soluble, releases extra nutrients, and then finally to get energy is a good answer as well. So I would have got 4 marks for that. Okay. Now, label diagram shows most of the organs involved in digestion and associated processes in our body. State one function of each of the 5 labeled diagrams. Okay, let's do this. Stomach, I think we have this. Churns food or digests food mechanically. Some of you might say does softens the food using stomach acid. Liver produces bile. Bile used to digest food. Pancreas produces enzymes used to to digest food. Small intestine. Let's see what the small intestine does. Sometimes I'm a bit hazy. Small intestine completes digestion, allows food into the bloodstream. I like allows food into the bloodstream. That's a good one. Allows food into the bloodstream. Also completes digestion. Okay, large intestine reabsorbs water into the body. I'll use a different one this time. Reabsorbs water into the body from food into the body. Sorry, it doesn't reabsorb it from food. It reabsorbs it from the reabsorbs water into the body. We'll just say that reabsorbs water into the body. Okay, there absorbs water or into the body. Okay. Now let's move on to the next one. What do we have next? Okay, what is the function of the Bugs Bunny teeth, which is the incisor, which is used to chop and slice food? What's the function of B? To grind and crush food. It's a molar at the end. Okay, that's question 14 done. Okay, question 15. Choose a substance from the diagram that is acidic. You can go for vinegar or soda water. Anything below a pH of 7. Basic, I can go for oven cleaner. And then basically neutral, it has to be pure water. Say how a student could measure the pH of the substance above by placing a sample of the substances. Now litmus paper won't work because litmus paper will only tell you if it's an acid or a base. You have to use universal indicator and match the color to the chart to find the pH, or a pH meter, whatever you want. And measuring the pH. With a pH meter. You could also use universal indicator and then match the color to the chart to find out what the pH of the substance is. That's a longer answer, just didn't really want to write it. Okay, but you can do that. Lemon juice has a pH less than 7. Describe how a student could find a pH of lemon juice. Okay, I refer you to the same answer as last time. By placing a sample of the substance or sample of the lemon juice in a beaker and measuring the pH with a pH meter. Okay? Good job. Name one material or substance which could neutralize lemon juice. Any base material, so we could probably use baking soda from the last part. So baking soda. Identify a metal that reacts with HCl. Magnesium will do the job. And when magnesium and HCl mix, they produce hydrogen gas. Okay. Now we're on to 18. So this is a acid and a base. Okay. So imagine the acid has a pH of, I don't know, like 3, and the base has a pH of, I don't know, 8. What will happen is when you add more and more drops of the acid into the base, so I'm going to color the acid in red. When you add the acid into the base, what happens is the pH of the mixture will eventually, imagine the base starts off with pH of 10. When you throw the acid into the base, it will eventually lower the pH. It will go to 9, then it might go to 8, and then eventually you could end up neutralizing them both. When you neutralize them both, you end up producing salt and water. This is when the pH goes to 7. Okay, so let's figure out some of these answers. What is the name of the reaction between acid and base? It's known as a neutralization reaction. Okay, name 2 products generally formed in a reaction between acid and base. Salt, and then we have water. the diagram has an experimental error. What is the experimental error? Well, if you look at see what you have on what's called the burette. The burette is the object with the acid in it. It's a tap. Okay, so you have what's called a burette. Okay, and on the burette there is a tap, and when you turn the tap, it leaks the acids into the beaker. Okay, but what you have to do is, let's say it says on this point here, let's say it says 50 centimeters cubed of acid. That's not true unless below the tap is also filled. So you have to make sure to fill below the tap to fill below the tap on the burette. Okay, and we're all good. Let's see what so burette not filled below the top. Top of burette is open. Should have used a conical flask instead of a beaker. No white tile, no stand, no clamp. So just the burette one's the best one there. Okay, so let's continue to move on. 19. Describe how to measure the pH of a lemon juice. I think we've answered this one already. I might just copy and paste it over again. So I'm just going to grab this here. Hopefully I can get my full answer. Just copy and paste this for the amount of times I have to use it. And paste. There you go. So just there. Now place a sample of the lemon juice. Okay, so lemon juice. We're good to go. Okay, question 20. Select a substance from the list with a pH less than 7. Orange is an acid. Orange juice. Okay, and then pH greater than 7 would be washing soda. Picking the easy ones. Okay, I'll give you a complete list now. Acid is orange juice, rainwater, vinegar, sour milk, or cola. And then basic is toothpaste, bread soda, milk of magnesia, and washing soda. Okay, any of those. Name the acidic substance. We'll go for soda water. Basic substance, toothpaste. And finally, neutral is pure water. Okay, let's move on. Now, this is the one I want to do. It's sort of like towards the last question in the chapter, right? And I want to use this one differently, right? So here's what we're going to do. See the antacid? That's a solid, okay? And what I'm going to do is the antacid. Dissolve 2 tablets of antacid in a beaker of water. Stir until all the antacid is dissolved. I'll do it differently this time. I could use the pH meter, but I won't. Add a few drops of universal indicator in, or dip a universal indicator paper into it. Add a few drops of universal indicator and match the color of the solution to its pH using the colour scale. Okay. Describe an everyday substance with pH less than 7. We just go for orange juice again. Okay. And we're done. That took me all of